All right. Today you're going to get an introduction to vectors. Vectors. Um, I wish we were live together in class and I could show you this cute little 1 minute little clip of the movie, Despicable Me, where he talks about vectors and what it means. It's super cute. So if you want to, if not, when you're in pre-calc with us next year, you'll see the little clip in class. But if all you have to do is Google Despicable Me vectors, and you'll come up with a YouTube video that's just a 1 minute little clip of him talking about his name he goes by is Vector. Anyway, because he's committing crime with both direction and magnitude, and it's super cute. But all right, so what is a vector? Well, a vector, and I can't show the clip on here because otherwise YouTube will flag it and not let me post the video. They'll pull it down. So copyright and stuff, whatever. All right, so what is a vector? It is a quantity with both direction and and magnitude. And by magnitude, we mean length. I think you're probably all too young to have taken any physics yet, but velocity is an example of a vector. Velocity is the perfect example. Maybe you guys have seen velocity somewhere else, but anyway, so what is a vector? Well, it is a quantity with both direction and magnitude. So that means you will have an arrow, right? That's saying it's not just a line. It's showing that it's going from here to there in that direction. We call this guy the tail. We call this guy the head. And the length of this line is what we call the magnitude. All right. And so when you write it, your book may use bold lettering to represent a vector. But when you're writing it on paper, you can't write a bold letter. And so what you're going to do is you'll write an arrow over the variable. And that's how you represent a vector. So, like for example, A, it's not just going to be side A anymore. It's going to be A with a little arrow on it, or B, you'll draw a little arrow over it, or C, and you'll draw a little arrow over it, and that means you're talking about a vector. Some properties of vectors is, first of all, two vectors are equal if they have the same length, and same direction. Um, so that what that means is your vector, you could start off at any point on that or on the coordinate plane, right? And as long as the length is the same and it's pointing in the same direction, you can slide that thing anywhere over the coordinate plane, and those two vectors would be totally equal. Um, a vector is a directed line segment. Directed line segment, like what I wrote there. It's what I drew. Looks like a line segment with an arrow on it because it's got a direction. And if I write the absolute value of vector A, this is how we represent its magnitude or length. All right. To add two vectors together, there's a couple ways of doing it. There's two different ways to do it. So vector addition. One way to do it is to place them tail to head. And that would be like, let's say, I'll write over here. What if, let's say that's vector A, and let's say this is vector B. Not messy. Let's say these are my two vectors, pretending like I actually drew straight lines. Oopsies. Okay, so one way is to place it tail to head. And what that means is if I want to do A plus B, I would start by drawing A again and try to duplicate the same direction and length. And then if you place the tail of B onto the head of A, looks something like that. Again, trying to duplicate the same length and the same pointing in the same direction. And then if you draw a vector from the tail of A to the head of B, this would be A plus B. This vector here, I guess I should draw it in a different color maybe. It's A plus B. So that's the tail to head method. The other way to do it is the parallelogram method. So parallelogram. In the parallelogram method, what you'll do is you'll do tail to tail. Tail to tail. Meaning you'll start them both off, tail to tail. You'll start them at the same spot. So I'm going to duplicate A the best I can of same direction, same length. B, I'm going to start it there. I'm going to put their tails together and draw it maybe like that. There we go. Again, I tried to do the same direction, the same length. And then what you do in the parallelogram method of adding two vectors is you finish off what would have been the parallelogram. So remember, a parallelogram has parallel sides and equal in length. So I would finish off. Those are what would have been the sides of the parallelogram, pretending that those actually match. And then your answer, the A plus B, is going from where the two tails are connected from their starting point to the opposite diagonal. So I should have done a different color. There you go. Do you see that? Pretty close. Yeah, not too bad, not too shabby, Mrs. Bright. Nice. Okay, so yeah, it doesn't matter which way. There will be times when parallelogram method is what's going to make sense because you got to put your two tails together. There'd be times where tail to head method because you got to put them that way, or sometimes you can just choose whichever way is more convenient for you. If you do vector addition or subtraction, rather, what if we ask you to subtract? Well, all you got to do is change it to an addition problem, right? A minus B is the same thing as vector A plus negative B. You agree? 2 minus 3 is the same thing as 2 plus negative 3. So that's the same thing. And what does negative vector B mean? It means it has the same length. It's just in the opposite direction. It just means flip your arrow to the other side. So I'll use those same vectors. Vector A is what I would start with. I'll do the tail to head method, yeah? So A plus negative B would be, if here's A, looks like it's about like that. There's vector A. Negative B means I'm going to take the same vector, right? So the same length, about like that, right? But then I'm going to flip the arrowhead and point it that way. That is negative vector B. And then your tail to head method, you're going to start at the tail of the first guy and using a different color, draw. Here we go. This is A minus B because it's A plus negative B. There you go. So the pink one is the final. The pinks on all of these were the final answers. We just had to use the other vectors to do it. Okay, there we go. We can also ask you to find angles between vectors. So let's talk about that. Let's do an example. If I tell you that the magnitude or length of vector A is 5 and the magnitude of vector B is 9 and the angle between the two vectors, I guess we're not going to find the angle this time. We're going to find, okay, all right, okay. So, and the angle between the vectors is, I'm going to call it theta, 53 degrees. They want us to find the magnitude of A plus B. Okay, so when they tell you the angle between the two vectors is a certain thing, you have to do them tail to tail. Now, you've got to point them in the same, starting at the same point when they give you the angle between them. And so what I usually do is I'll draw one of them horizontal because it's just the easiest. Draw one horizontal and I'll make that the longer one, right? And then 53 degrees would be about, maybe a little bit less than that. And then I would draw vector A, which is about half the length. Okay, so I'm saying that's 53 degrees. Yeah, and I'm saying this is vector B, which is 9, and vector A's magnitude is 5. Yeah, so that's vector A and that's vector B, and the angle between them is 53 degrees. So here, tail to tail, you have to finish off the parallelogram. Try to make it as parallel as possible. Parallel, parallel, same length. Parallel, parallel, same length. All right. So do you remember that? Because here's the deal. What we want is they're wanting us to find the magnitude of A plus B. So A plus B is going to be the vector going starting from where these two guys are starting and then to the opposite diagonal. So that's what we want. And we want the length of that diagonal is what we're really wanting when they're asking you for the absolute value there. Well, here's the deal. This guy does not bisect 53 degrees. You can't just chop it in half. It's not, you can't. It just doesn't happen that way. It's not one of the rules of parallelograms. So how you have to do it instead is, first of all, recognize that it's a parallelogram. So that means if this side is 9, then so is this side is also 9. And if this side has length 5, so does this side. So you do have to realize the opposite sides are going to be the same length. And then what you really need is this angle here. Because then you've got side angle side of, do you see that you would then have a triangle that looks like this. This is 9 and that's 5 and this is the A plus B that you're trying to find the length of, right? And then if you have got that angle there, then you've got a sassy triangle. Side angle side. Nice. Okay. Do I know what that one is? Well, there's the rule of parallelograms. Do you remember it from geometry? This angle right here will be the supplement of 53. So you'll just find it by doing 180 minus 53 degrees, and that'll give you 127 degrees. So that's what goes there. Yeah, you got a side angle side triangle. You're going to use law of cosines. All right, law of cosine says that this side opposite the 127 degrees, the length of that guy squared will be side squared plus the other side squared minus 2 times the side times the other side times the cosine of 127 degrees. And so then you'll take the square root of both sides to get that this magnitude of a plus b, well, it will equal the square root of that whole craziness. So let's put it in our calculator. I'm going to have square root of, covering it, what is it? Square root of 5 squared is 25, 9 squared is 81, minus 2 times 5 times 9 times the cosine of 127. Boo, boo, boo. And you get that magnitude of a plus b is about 12.655. So I'm going to say a plus b magnitude is about 12.66. That was equal. And then I rounded. All right. Then, same information, but now they're going to ask us to, so here's that was part A, I guess. And then part B is going to be find the angle that the vector A plus B makes with vector A. All right, so what are they looking for this time? What other colors do I have? Oh, green. The angle that A plus B makes with A, here's A plus B, and here's A, the way I drew it. So we're looking now for this angle here. And so now I'm looking at this triangle here. So let me redraw it. I would have A, and didn't really do that very well, did I? Let's try it again. Here's vector A plus B, and then there was a little, yeah, I did not make that to scale at all. Sorry about that. This is still A, this is still 5, right? And this is A plus B, and this was, I know it wasn't vector B, but it has the same length as vector B, so this one is B. And so this side is 9, and this side is 5, and this side we just figured out is about 12.66, and we want this angle here. And how about if I call it theta? It's the same as the green above. Yeah, so I know I didn't draw it to scale. Sorry about that, but whatever. Okay. Do you see that now I'm trying to find this angle theta, and I have a side, side, side triangle. You have a snaky. That's snaky. And you're going to use law of cosines again. All right, so this time it's angle theta I'm trying to find. So the side opposite is 9. So you'll have a 9 squared is equal to 5 squared plus the 12.66 squared minus 2 times the 5 times the 12.66 times the cosine of angle theta. Technically, I should have stored 12.66. So if you're, oh, let's see if we're off. I should have done it, but I didn't. So whatever. Okay, remember you're solving for this guy, and it's 81 equals 25 plus, this is going to be 100 and something, right? Minus, and then all of these guys are attached to each other with multiplication happening, right? So you can subtract, in fact, I'm going to keep it the way it's written. 9 squared, I'm going to subtract 5 squared. I'm going to subtract the 12.66 squared. parentheses around it, right? And that's equal to the negative 2 times 5 times 12.66 times the cosine of theta. Yeah. And then I'm going to divide by the number that's in front of cosine of theta. So I'm going to still have a 9 squared minus 5 squared minus 12.66 quantity squared divided by the negative 2. Technically, that's like times, right? Times 5 times 12.66. And that's equal to the cosine of theta. And then to solve for theta, you need to take the inverse cosine of both sides. And so it ends up being that theta, the angle, will be inverse cosine of 9 squared minus 5 squared minus the 12.66 squared over negative 2 times 5 times 12.66 is equal to that angle theta. Yeah. Okay. So make sure when you put this in your calculator, let your calculator know this whole top is in the top and this whole bottom is in the bottom. Yeah, you got to let it know that either that or figure out what this decimal is and store it, figure out what this decimal is and then store it, and you can use your stored values. That works as well. But I'm going to just put it in the way it is. All right, so I've got inverse cosine of, start a new parenthesis, right, to say this is the numerator, 9 squared minus 5 squared minus 12.66 squared, end the parenthesis for the numerator part, divided by, start a parenthesis for the denominator, and now I've got negative 2 times 5 times 12.66. You could end the parenthesis and then for here and then end it for the outside guy. Your calculator doesn't care if you end all the parentheses, and I'm lazy with it, so I'm just going to hit enter. 34.546. And had I stored everything, my answer would have been different. Darn. All right, well, whatever. Theta is about 34 point. I was really naughty. I should have stored. If you had stored the A plus B value, yeah, and used that, right, then your theta is we're actually off by a tenth. Theta would be about 34.61 degrees. So there. I'm teaching you a good lesson on why you should definitely store your values, right? Because that's off by quite a bit, and that's what will happen. So if you had gone back here and had done the whole decimal, store this value, store it under A, right? And then every time you see this 12.66, you're going to use that stored value, stored value, stored value, stored value, all of those guys, stored values, and then that's really the proper answer. So if you're not storing your values and you go to check your answers in the back of the book, your answers will be wrong because they stored values and didn't round. So, all right, now part C wants you to, same information, we're going to find the magnitude of A minus B. All right, so let's draw it out first. My B is what I had done for the horizontal. Well, okay, so I'll draw that again and do the same length, but now negative B, right, is now pointing this way. Starting here, but pointing in the opposite direction. Same length. A, I'm going to put it as on its tail. There's A. I put them tail to tail, which means you'll finish off the parallelogram. Yeah. And remember, they gave us that between A and B, this angle right here was 53 degrees. Yeah. And that, yeah, there you go. Okay, so and side A was length 5, so I'm saying that's 5, and that's 9, and so this is 9 also. So that's 9. Magnitude of that is 5. Yeah, and we want A minus B, which is from their tails to the opposite diagonal. This is A minus B. And we want the magnitude of that. All right, do you say it? I've got this triangle right here, side, angle, side. Yeah, and this time I'm using the 53 degrees. So it is the magnitude of A minus B, quantity squared, is equal to side squared plus the other side squared minus 2 times the side times the cosine of the angle in between them, which is 53 degrees. And when you put that in your calculator and you take the square root, it ends up giving you, let's store it this time so that way we're good boys and girls, right? So I'm going to do the square root of 25 plus 81 minus, what is that, 90 cosine of 53. And I get a 7 point, all right, if I'm going to 2 decimal places, well, let me write it, 7.19976, blah, 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 blah. So I'm going to say that it's about 7.20 for that magnitude, but I'm going to store this because this isn't the last question. I'm going to ask you something else right now. Ready? So I'm going to store it. It's stow, and I'll store it under A because I'm done with that other A value. And now A, when I recall it, it'll bring up that whole long decimal. All right. So now part D, and then this is it, promise. We're going to find the angle between the vector A minus B and vector A. So what we're wanting now is the angle between A minus B and A. So I'm looking for this angle here now. The green theta. Now, all right, I'm going to redraw it over here. So now I only need that, and that. Where this is a 9, 9. And this is A minus B, which we just found. And I want theta, and this is 5. And this was about 7.2. So now I've got snaky again. Yeah. And so I'm going to use law of cosines. And I'm looking for theta. So I'm using 9 over here. So it's a 9 squared equals 5 squared plus 7.2. But I'm going to use my stored A value squared. Yeah. Because I stored this one, I stored under A. Stored A. Yeah, I'm going to use that stored value to show you, like, this is really what you should be doing so that you get proper answers. Okay, so we got stored A value, and then minus 2 times 5 times that stored A times the cosine of theta. Yeah. So then when I subtract all these over, it'll be a 9 squared minus 5 squared minus, I'm just going to write A squared, right? And then divided by negative 2 times 5 times A. And then that's, and then you'll take the inverse cosine of both sides, and that's what will equal theta. Yes, I know that. I did it slower on the last one, but subtract, subtract, divide, and then inverse cosine of the whole thing. All right, you ready for it? Let's see. All right, so I've got my stored A value. All right, and in fact, you can confirm it by memvar, A is underlined. There you go. If you have more to store, you can absolutely use B, C, D, E. It doesn't matter. Okay, so get out of there. All right, so I'm going to do inverse cosine. Oh, and don't forget, parentheses around the top. And at the very least, start one here. Yeah, that's all you got to do, and then you'll get the right answer. Okay, so inverse cosine of start a parenthesis. And I've got that's 81 minus 25 minus, and that's just because I squared them because I don't want to hit the square. Memvar A, enter. Yeah, square it, and the parenthesis for the numerator, divided by, start a parenthesis for the denominator, and then it's -2 times 5 times memvar, memory variables, I guess, A. And you get theta is about 93.315. So I'm going to say 32 degrees. There you go. And if you hadn't have stored it and you had said 7.2, all of that stuff would have been off. So better to store so you get the right answer. It's in math always. Like when you're using your calculator, then you want to store things until the very last step. Okay, that is section 7. I just want to tell you guys, I miss seeing your face. This is very lonely for me to just do these lessons without you in person. And it just makes me sad. We're not going to go back to school and I'm not going to see your faces until next year. So come see me in office hours. Hopefully it's all making sense. And you all have a fabulous spring break. I want you to relax and so read a good book. Yes, read it just for fun. It's such a difference when you get to read a book for fun instead of having to read it for English. Yeah, find a fun book to read or watch some Netflix. I don't know what you can do. Go on a FaceTime with friends and hang out and chat and laugh and have fun. And anyway, I hope you all have a fabulous week next week. Relax. I know I'm going to relax and I can't wait, but I still miss you all. Okay. So have a good one and I'll talk to you later. Bye.